This example is on lines and circles. So it says find the point of intersection between the line and the circle. So thinking back to when we did algebra, we were able to solve using simultaneous equations. Same kind of idea here. So we've got our original, this is the line and this is the circle. So our line, we need to get either x or y on its own. Much easier here to get x on its own. So it's going to be 1 is equal to 1 minus 2y. And then whenever we see x in the second one, we're going to sub that in. So it's going to be 1 minus 2y squared plus y squared plus 2 by 1 minus 2y plus 8y minus 8 is equal to 0. And then we're just going to do a lot of working out here. Square the first, square the last, first bit last by 2, plus y squared plus 2 minus 4y plus 8y minus 8 is equal to 0. And then we need to add our x squareds together. So we have 5y squared. You can see the y's actually cancel each other out. And then we're left with minus 5 is equal to 0. So then from that, we can divide across by 5. So it's y squared minus 1 is equal to 0. So using the difference of two squares, y minus 1, y plus 1 is equal to 0. So y is equal to plus 1 and y is equal to minus 1. So there's my two values for y. To find my two values for x, it's easiest if you just sub them back into the original, using y is equal to 1 first of all. X is equal to 1 minus 2 by 1. So x is equal to minus 1. Our point here is minus 1, 1. And then the second one is when y is equal to minus 1. Sub it back in. And our other value is equal to 3. So our point is 3 minus 1. Moving on to the second example. Actually, just before we do that here, you should always know if there's going to be a point of intersection between a line and a circle, it generally crosses at 2 points, like this, as long as it is not a tangent. If it's a tangent, it's only going to touch it at one particular point. So this one here, example 2, it says find the point of intersection between the line and the circle and hence show that the line is a tangent to the circle. Now, just like I've just said in the previous question, if it's going to be a tangent, there's only going to be one point of intersection. And that's how we'll find that information out. So for this one here, it's much easier for the line if we just get y on its own. So y is going to be equal to 2x plus 8. And then we sub that in for y in here. So it's going to be x squared plus 2x plus 8 squared plus 4x plus 2 by 2x plus 8. And that is equal to 0. We're going to work all of this out. So it's going to be x squared plus 4x squared. First bit last by 2, so that's plus 32x, and plus 8 squared, which is 64, plus 4x plus 4x plus 16 is equal to 0. For all of this multiplying out, feel free to take a few extra steps yourself if you're having difficulty with that. Then what we need to do is add all our x's together. So we've got 5x squared. We have 32 plus 8, which is plus 40x. And then 64 plus 16 is plus 80 is equal to 0. Much easier for ourselves here if we just divide across by 5, simplify it all down. So it's x squared plus 8x plus 16 is equal to 0. Find our factors that give us 8x in the middle. So it's going to be x plus 4 and x plus 4. So my x is going to be equal to minus 4. So we've only got one value for x. Then we need to sub it back into the original to get our value for y. So y is equal to 2 by minus 4 plus 8. So y is equal to 0. So our point of intersection is minus 4, 0. And then it says, hence show that the line is a tangent. We would write down only one point of intersection. Therefore, tangent. Okay, like I showed you on the previous one. You can even draw a diagram just to kind of show it a bit further if you like. Okay, so there's only one point of intersection, therefore it has to be a tangent, because if there was going to be 2 points, it was going to be couldn't possibly be a tangent.